It's time we talk about the moon, mostly because of the recent announcement from India and because of other additional discoveries from other scientists. We're going to be discussing in this video. Hello everyone, this is Sean, and let's discuss our beautiful neighbor. Let's just jump into the biggest story that everyone by now has heard of. India finally made officially becoming the fourth country to soft land on the surface of the moon with a recently launched Chandrayaan-3 spacecraft. Developed by learning from mistakes of the previous Indian mission, in a nutshell, Chandrayaan-2 that crashed on the moon in 2019, moreover becoming the first nation to land very close to the lunar south pole at approximately 69 degrees in latitude. And because this mission comes with a rover, it's now going to allow Indian scientists and by extension humanity to explore the polar regions of the moon where we know some craters never get any sunlight and could thus hide permanent water ice. But this is obviously not just a mission to learn how to land on the moon. The rover is also going to do a little bit of science. It's known as the Pragyan rover, and it's going to try to collect and examine materials from the lunar surface, while also using spectroscopy to test for various elements, and another probe to test for plasma density on the lunar surface. Although by itself, that particular part of the mission is going to be relatively short, only 2 weeks mostly because, as you can see, it relies on the solar panels. With the lunar day being 2 weeks, and so it's assumed that it's going to be too cold for the rover to survive, and without sun, it's unlikely to function afterwards. But what makes this mission particularly interesting is the total cost. It was only about $75 million, way cheaper than anything else by NASA or other space agencies. And though this might actually sound like good news or something to be proud of, which I'm sure a lot of these scientists are, they're definitely very proud of their achievement. And of course, I have to congratulate everyone involved in this mission. It also shows that a lot of these people are very likely completely underpaid for their skills, a little bit unfair to be honest, and maybe something for India to consider in the future. Give them a raise, they just landed on the moon. Anyway, everyone's definitely super happy and extremely proud. One of the main reasons this mission now succeeded is because of those specific lessons from 2019. For example, here one thing they did differently is replacing 5 engines with just 4 in order to increase stability. It's now believed that it was the 5th engine that potentially caused Japan's lander collision back in 2019. But even though India has now become the 4th country, the 5th country might be Japan. This one right here, JXA's Slim Lander, is most likely going to be the next contender, also developed based on previous lessons from the previous crash. But the biggest mission planned for next year is going to be NASA's Viper, Volatile's investigating polar exploration rover, that's going to be launched in November of 2024. And so it looks like the moon race might have started once again. But we'll see how all of this goes in the next few years. This is of course particularly exciting because of all other recent failures from other countries and other companies. We discussed the failure of our lander by Japan, which basically crashed on the moon, and Israel's Beresheet lander that also crashed there as well. But we can also add Luna 25 to this list that recently crashed here as well. This was the Russian attempt after approximately 47 years, and that really doesn't look good for Roscosmos. Oh well, too bad. Moving on to the mission that beat India by just a little bit. The Chinese Chang'e E4 mission that basically landed a similar rover exploring the moon's even farther side. The U-22 rover that you can see right here was recently able to conduct a very thorough scan of the lunar surface, going as deep as approximately 300 meters. The first such scan conducted by any probe in a process revealing quite a lot of detail about lunar regolith and what's essentially right underneath. As always, you can find the study in the description. But in the last few months, it was able to visualize various layers underneath the lunar regolith by using what's known as LPR, Lunar Penetrating Radar. Now, they previously tried this back in 2020, but only up to approximately 40 meters. But this time, they were able to do this much deeper. First, uncovering the information about the upper surface crater produced by an asteroid smacking into this area, but then discovering 5 distinct layers showing different types of lunar lava, suggesting that we're now looking at different layers of volcanism that happened on the moon billions of years ago. With the main discovery being that a lot of these volcanic rocks seem to actually grow thinner and thinner the closer to the surface they got, which provides evidence for something that was kind of known already. The volcanism on the moon used to be huge and quite dramatic, but decreased over time, stopping completely approximately 1 billion years ago. And though there have been signs of more recent volcanism, for the most part, it all stopped roughly around 1 billion years ago as presented in this study. And so this suggests that the moon was basically cooling down. It was decreasing in volcanism. But there were at least 3 separate major volcanic flows detected in this area of the moon. Because the moon does not have plate tectonics and because everything here just stays on the surface, by going deeper and deeper into the lunar surface, we are going back in time. And so here it was possible to see several billion years into the past. But obviously, this is just the first such analysis and the first such study. A lot more will probably be uncovered in the next few years. Then we had another really unusual discovery in regards to the effects the moon has on planet Earth, or to be more specific, on the formation around the Earth, sometimes referred to as the plasma ocean or plasmasphere. By itself, this formation is a result of the magnetosphere of the planet and represents this unusual donut-like shape surrounding our planet at all times. But even though we assume that most of the effects were coming from the sun and not from anywhere else, there's now evidence that this plasma ocean is also affected by the moon, and specifically in pretty much the same way as the motion of the moon affects our oceans, the tides. It looks like the moon creates various types of tides in the plasmasphere of the planet. This was part of a mission known as Feasible Time History of Events and Macroscale Interactions During Substorms, THEMIS, that was studying the magnetosphere of planet Earth for many years. And as it passed through various locations around the planet, certain patterns started to emerge, specifically patterns mimicking the motion of the moon, as if the moon was producing tidal effects in the plasma ocean. And so this entire donut ends up being shifted and moved around, similar to the oceans on the planet, which though might not matter to us on the surface of the planet. When it comes to things like satellites or any kind of space exploration mission, this actually becomes super important. By knowing exactly where the plasmasphere is and by understanding how it shifts around and how it moves around the planet, it helps us predict how the planet's magnetosphere is going to respond and where things like, for example, Van Allen belts are going to be located as well, which is going to be super important for any future lunar missions. And then we had some other exciting experiments conducted right here on planet Earth. Here's the team behind one of the most exciting experiments that used this relatively large chamber to mimic lunar conditions and then successfully extract oxygen from various types of lunar soil, or actually artificial lunar soil that you can technically buy online. And this was the first time ever that this extraction has been done in complete vacuum, suggesting that it's going to be possible once we finally land here and try to create a colony. And so by using a very powerful laser to mimic solar energy, they were able to melt all of the lunar soil within what's known as a carbothermal reactor. Normally, these are reactors used for producing things like solar panels or even steel. But by modifying it a little bit, it becomes possible to extract oxygen from lunar rocks. Intriguingly, a very similar device is very likely going to be launched sometime soon during the polar resource ice mining experiment that's going to be conducted on the moon. And the previously mentioned NASA's Viper mission is very likely going to contain something similar too. So both of these missions are now going to test very similar technology, attempting to extract oxygen both for human use and to possibly create fuel. But despite all these exciting achievements and somewhat good news, there's also at least one study that presents a bit of a problem. That lunar dust we discussed that can be used to create oxygen is also a potential hazard. And not just any hazard, a major hazard, especially for any long-term mission, because this regolith, all of this lunar dust is very different from anything we have on planet Earth. First of all, it's electrostatic in nature. It's also super sharp and tends to attach to everything, making it very difficult to get rid of. On top of this, because of its unusual properties, it's extremely fine but also extremely viscous, so it's very difficult to walk through, and it's also extremely difficult to drive through. But most importantly, it's extremely dangerous. If you breathe it in, it has a tendency to basically get stuck in your lungs, potentially resulting in major health hazards. And if that wasn't enough, there is something else. During any kind of a lunar landing or lunar takeoff, by blasting the engines, we would actually be creating a huge amount of blowback with all of this dust moving extremely fast, possibly several kilometers per second. And because it's so sharp and so hard, it might act as a kind of a sandpaper, slowly eroding everything in the vicinity. Solar panels, glass windows, and anything else that's not designed to be super hard. But even more so, the recent study suggests that the lunar gateway that's going to be orbiting around the moon in the next decade or so might sometimes have a chance to be affected by this, with up to 4% of surfaces being destroyed every time it passes close to a rocket taken off. And that's despite the fact that it's going to be in lunar orbit away from the landing facility. And so this dust is going to be traveling everywhere, very, very fast, destroying everything in its path. So at least for now, this is definitely going to be one of the biggest hazards for future missions and for any kind of colony established on the surface. But other than that, at least for now, that's kind of all I wanted to mention. Super exciting announcements, somewhat exciting discoveries, and some new stuff we never knew before. The moon's allure is undeniable, but it demands respect and resilience. Join me next time as we explore potential solutions for lunar colonies, including magnetic levitation railways and jumping rovers. Until then, keep your eyes on the moon and your dreams among the stars. Don't forget to hit that subscribe button, share the wonders of space with fellow enthusiasts, and I'll catch you in the next cosmic rendezvous. Stay curious.